Welcome to the Unit 2, Section 1 video on graphing and writing inequalities. Let's start talking about inequalities by identifying the solutions of inequalities. So, an inequality is a statement that two quantities are not equal. The quantities are compared by using one of the following signs. We have less than, so this is read as A is less than B. Greater than, read as A is greater than B. Less than or equal to, read as A is less than or equal to B. Greater than or equal to, where it's read as A is greater than or equal to B. And there is one more inequality that a lot of people tend to forget about, and that is not equal to. That is an inequality because it indicates that the two sides of the equation are not equal. So A is not equal to B. A solution of an inequality is any value of the variable that makes the inequality true. So let's talk about what a solution looks like. We're going to describe the solutions of 3 plus x is less than 9 in words. So we're going to test values of x that are positive, negative, and 0. So I've written a little table here, and we're going to start with putting in negative 2.75 for x. When you substitute that in, 3 plus negative 2.75 gives you 0.25. And if you put that solution in on the left-hand side, you do find that you have a true statement. 0.25, or 1/4, is less than 9. So that is a solution. How about 0? 3 plus 0 gives you 3. And you put that on the left-hand side. 3 is less than 9. So that is also a solution. How about 5.99? That gives you 8.99, which is less than 9. So that is also a solution. But if we put in 6, that gives you 9. 9 is not less than 9. 9 is equal to 9, but it's not less than 9. So that is not a solution. 6.01 gives us 9.01. That's not less than 9. It's greater than, so that's not a solution. And the same for 6.1. That's also not a solution. So the way we can describe this is the solutions of 3 plus x is less than 9 are numbers less than 6. It's all well and good to be able to describe the solutions of inequalities using words, but it's more efficient and easier to follow if we just graph the solutions of inequalities. An inequality like 3 plus x is less than 9 has too many solutions to list. There's no way you can list every number that is less than 9. So you can use a graph on a number line to show all the solutions. And in this case, we say that it's all numbers that are less than 6. So we indicate less than by using an open dot because it's not equal to 6, it's less than 6. So we're not including the 6, so we use an open dot, and then we shade all the numbers that are less than 6. The solutions are shaded, and an arrow shows that the solutions continue past those shown on the graph. We go forever to the left. We go forever in that negative direction. To show that an endpoint is a solution, we draw a solid circle at the number. To show that an endpoint is not a solution, we draw an empty circle. So here, 6 is not part of the solutions, so we use an empty circle. So we're going to graph each of these inequalities. For v is less than 2, we're going to use an open dot at 2, and we're going to shade to the left for all the values that are less than 2. For b, we have x is less than or equal to 3. So we're going to close the dot at 3 since we're including it, and we'll shade everything that is less than 3, which is all the numbers to the left. For n is greater than or equal to negative 1, again, we're including the negative 1, so we use a closed dot. Since it's all the values that are greater than, we're shading to the right. And for b is greater than negative 4, we're using an open dot because the negative 4 is not included, and we're shading everything to the right. Now look at all of these graphs and look at the inequalities. You'll notice that the direction of the inequality sign points in the direction that we shade on the graph. Be careful about using this shortcut when graphing because it only works when the variable is on the left. That is when you start with the variable in your statement. So, what if the variable is on the other side? We're going to rewrite the inequality to make our graphing a little bit easier. We're going to put the variable on the left. So to do this, we're going to flip the entire inequality. We're going to move the variable to the left side, we're going to move the constant to the right side, and we're going to flip the direction of our inequality sign. So for these examples, our variables are on the right side, not the left. So the first thing we're going to do is we're going to flip our inequality. So in A, we're going to move the A to the left and the 4 to the right, and we're going to flip the direction of our sign. Then we're going to use this to do our graph. We're going to have an open dot at 4, and we're going to shade to the left. For B, we have N being moved to the left, -2 being moved to the right. So we're going to swap the left and the right side, and we're going to flip our inequality. So N is greater than -4. Open dot at -4, and we're shading to the right. For C, flip our two values, flip our sign, and that gives us a closed dot at 2 and shading to the left. And then for D, flip everything and then put our closed dot at -1 and shade to the right. Now we can write an inequality from a graph using the same principles that we did to create the graph in the first place. So for example 4 here, we're going to write an inequality shown by each graph. So for each of these graphs, I am going to start with my variable. For A, I'm going to start with x. I'm going to write my inequality in the direction that the arrow is pointing. So in this case, we have a less than. Since we have a closed dot at -4, we include the equals to, and then our value here is -4. For B, we start with our variable. We have an open dot, so it's just going to be greater than, and then we have -6 as our value. For C, we're going to have an equals to as part of our inequality. It's going to the right, so we have greater than or equal to, -2. And then finally for D, our variable leads us off. We have an open dot, so there will be no equals to, and we're going to be less than -5. Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.